Alright, so we just learned the general technique behind completing the square, looked at it from a geometric perspective with algebra tiles, where basically what you do is you take half of the middle term, whatever that number is, and then you square it. So let's try some examples with this. Find the value of c that makes this quadratic x squared minus 26x plus c a perfect square trinomial, and then put it all together as the square of a binomial. So I'm going to write down just the first part, x squared minus 26x. And the technique is this. I take half of this middle term. Take half of it. Half of negative 26 is negative 13. Now I'm going to take that number and I'm going to square it. And the square of negative 13 is positive 169. So my c value here from this equation is 169. That's what number it takes to complete the square. Now to write this thing as the square of a binomial, it's x, keep the same sign that's in the middle, minus, and 13. And that 13 comes from whatever I got after I took half of the middle term. All of this squared. Piece of cake. Let's try another one. A little bit tougher because now we have an odd number as the middle term. So the instructions are still exactly the same thing. I want to try to complete the square on this. X squared plus 7x. Okay, so the last one was easy just because it's an even middle term. I take half of it, I still get an integer. But here, whenever I take half of the middle term, I get 7 halves. 7 halves is the same thing as 3.5, but I'm telling you, leave it as a fraction. Leave answers as fractions. It's really important. The reason why I say this is because in your head, you think about it right now. I have to square this number to get it right up here. Is it easier to square 7 halves in your head or on a piece of paper, or 3.5? Now, if you have a calculator, it makes really no difference because you just plug the thing in. But if I don't have to pull up my calculator and turn the thing on, it's a hassle. I can just square the top and square the bottom, and that's plus 49 over 4. And that's a piece of cake. But squaring 3.5 is a little bit more tedious. So C is 49/4. That's the number it takes to complete the square. And then, square of my binomial is x. I keep the same middle term, plus 7 over 2. That's half of the middle term. All of this squared. Nice square. Here are 3 of them for you to try. You have a couple of evens and 1 odd. Pause it, and then come back and see me. So what do you think? You think you got them? You think they were easy? Let's take a look. Alright, so on the first one, we take half of that middle term, take half of that thing, get 7, and you square the 7, 49. 49 is what it takes to complete the square, and then it becomes x plus 7 quantity squared. Okay, number 2, take half of the negative 22, get negative 11, square it, you get 121. Almost looks like absolute value 2, but it's not. And then square the binomials x minus 11 squared. And then finally, take half of the negative 9 halves, keep it as a fraction. Fractions. Keep them. Square that thing, you get 81 over 4, so that's your C. And then finally, x minus 9 halves squared is the square of your binomial. Alright, so haven't really solved the quadratic equation yet. Maybe we'll do that now. So, the technique, again, is to make the left-hand side a perfect square trinomial, and then take the square root of both sides. But on number 1 here, that's already the case. I already have a perfect square trinomial on the left side. This is x plus 3 squared equals 36. So now let's take the square root of both sides. X plus 3 is equal to plus or minus 6. Two answers, taking the square root, solving an equation. And then subtract my 3 over. X equals negative 3 plus or minus 6. Now these are just integers, so we can go ahead and add them up. So one of the answers is negative 3 plus 6, which is 3. And the other one is negative 3 minus 6, which is negative 9. Alright, you give it a try. Same kind of thing. The left-hand side is already a perfect square trinomial. Go ahead and see if you can solve it using that same method. Pause. So what do you think? You think you got it? Let's look. So on the left, perfect square trinomial is already made for you. It's x minus 5 squared. Go ahead and take the square root of both sides. You get plus or minus 1. Subtract the 5. And then simplify both your answers down. You got 5 plus 1 is 6, and 5 minus 1 is 4. Alright, so these questions were a little cheesy because the left side was already a perfect square trinomial. There was nothing for you to complete. So in an ordinary situation, it wouldn't be a perfect square, and that's what you have to work with. So let's take a look at this example. This example is animated step by step. I went to the trouble of going ahead and typing it up for you. Okay, so completing the square will allow you to solve just about any quadratic equation, regardless of whether or not it's a perfect square trinomial or not. Like, take a look at the one that I have. X squared plus 8x minus 6 is not a perfect square trinomial, but we can still solve it that way. And basically what we're doing is what you just saw in the previous part of the lesson, completing the square, and then we're going to use the addition property of equality. Whatever you add to the left side of the equation, you have to add to the right side of the equation. Okay, so look at that quadratic equation. I want to separate out the variable terms with the constant term. Take that 6 and go ahead and add it over to the right-hand side. Okay, in order to make this a perfect square trinomial, I need some sort of number that's going to complete that square. That's why I have myself a little blank right there. How do I get that number? Well, I take half of the 8, which is 4, and I square it, and it's 16. So that's the next step, is I'm going to add that 16 to both sides. If I added 16 to the left side, I have to add 16 to the right side so that the equation stays balanced. Alright, now on the left-hand side, we're just going to go ahead and factor that as the square of a binomial. On the right side, just add up those two numbers. So on the left, it is x plus 4 squared. On the right, you just got 22. Now go ahead and take the square root of both sides. And you get plus or minus the square root of 22. And then finally, subtract your 4 over. Can you simplify the square root of 22? Answer is nope, because you only have factors of 2 and 11 in there. So it's done. That's your answer. Piece of cake. So here are the steps typed out for you. Step by step, how do you solve a quadratic by completing the square. So the first one is you're going to use addition or subtraction to make your quadratic equation look like this. X squared plus bx equals c. In other words, if you have a constant term, go ahead and add or subtract it to the other side of the equation. Okay. Then you're going to complete the square on the quadratic side. Take half of the middle term and then square it. Whatever you get, you have to add that number to both sides of the equation. Finally, the side that you completed the square on, factor that, then take the square root of both sides and solve that equation. So let's look back at the previous slide so that you can see that in action again. So step 1 is to get rid of that negative 6. So I took that negative 6, added it to the other side. Step 2 is go ahead and complete the square on it. So you take half of the 8, you square it, you get the 16. Add that 16 to both sides. Now factor that side. X plus 4 quantity squared. The final step is to take the square root of both sides and then finish off solving it. So you take the square root of both sides and then finally subtract your 4 over. Let's give it a try. So I've got 3x squared minus 36x plus 150. Go ahead and write it down. 3x squared minus 36x, but I'm going to go ahead and subtract that over there. Let's get that step out of the way. Equals negative 150. Now, one complication is that we have a 3 out front. We didn't have the 3 out front before. But take a look at every single one of your terms. Every single one's divisible by 3, so let's divide them all by 3. And I get x squared minus 12x. I'm going to put plus blank equals, let's see, negative 50 plus blank. The blanks are there just as a reminder that I'm going to add something to one side to complete the square. Whatever I get, I'm going to add it to the other side. So let's complete the square on the left. Take half of that number, I get negative 6. Square it, I got 36. If I add 36 to the left, I'm going to add 36 to the right. 36. So on the left here I have x minus 6 squared is equal to, let's see, negative 14? Negative 14, I believe. Yep. Okay. And then what's the last step? Let's take the square root of both sides. So let's take the square root over here and over here. X minus 6 is equal to plus or minus the square root of negative 14. And then add our 6 over. 6 plus or minus square root of negative 14. Are you allowed to leave it like that? Heck no. I've got a negative inside that square root, so I need to bring that out as an I. So this is 6 plus or minus I square root 14. Of course, if that square root was simplifiable, you would simplify it, but that's just 2 times 7. There's no repeats, and so you're finished. Okay. So here are 4 of them for you to try. Do those steps just like we did on the previous one, and solve each one of these by completing the square. Go ahead and hit pause. Go ahead and hit pause. No. Go ahead and hit pause, and then come back and check your answers. Actually, why don't we just go ahead and start a new video?